All right, part C of number 1 says use the first 4 non-zero terms of this Taylor series about x equals 0 to find this integral about x equals 0. And we want to estimate the integral from 0 to 1/2. So the whole point here is we can't take the derivative of e to the negative t squared, or you can't take the integral because the derivative of the inside function is negative 2t and you don't have a t outside here. However, if you write the series, it's going to be written as a polynomial. And because it's written as a polynomial, you will be able to take the integral. So, so I've got this here, and I want to take the integral of this with respect to t. So I'll take the integral here as well, and just kind of follow through the pattern. So the integral of 1 is t, and then we'd have minus t cubed over 3 plus t to the 5th over 2 factorial. We got to divide by 5 as well. And it's going to kind of continue like that. Okay, that would be my integral. Now we're evaluating this between, they said between 0 and x. All right, so the fundamental theorem says we sub in x for everything. That would be x minus x cubed over 3 plus x to the 5th over 5 times 2 factorial. Or you could turn that into a 10 if you wanted to, and so on. We're going to subtract this if we substitute in a 0 for t. And that's going to be 0 minus 0 cubed over 3 plus 0 to the 5th over 10, and so on. And of course, these are all going to go to 0. So what are we going to be left with? Well, we're going to be left with this pattern x minus x cubed over 3 plus x to the 5th over 10, and you know, whatever that pattern is. They only asked me to use 2 terms here, so I'm not going to write out too many. Oh, they said the first 4 non-zero terms. Okay, so we need to go to one more. That would be minus x to the 7th over 7 times 3 factorial. If you look up here, raise the power by 1, divide by the new power. Okay, so that's what we're going to end up having there. So there our first 4 non-zero terms are. Use the first 2 terms to estimate the integral between 0 and 1/2. Okay, so we've actually already handled the 0 aspect here. We just need to sub 1/2 in. So the integral from 0 to 1/2 of e to the negative t squared would be approximately, and we're going to substitute in 1/2 minus 1/2 cubed over 3. And that, let's see, 1/2 cubed is 1/8. So this could be 24ths. This could be 1/24. So we'll write this as 12/24 minus 1/24 is equal to 11/24. Okay, and that would be our estimate here. All right. And then part D, we didn't officially do this, but if you take a future calculus course, it wouldn't be the worst thing to know. It asks you to explain why the estimate differs from the actual value of that integral by less than 1/200. That's a really small error, okay? Well, it turns out that the alternating series error, and this is an alternating series error, or this is an alternating series. The error, if you think about the demonstration that I did to show why alternating series converge if the terms go to 0, alternating series error is never going to be bigger than the first term that you omit. So it's less than or equal to the first omitted term. Anyway, the first term that we left out here, so we used these 2 terms. This was our first omitted term. So I can sub in 1/2 to that first omitted term, and I think you end up getting 1/320, okay? And 1/320 is less than 1/200, so we get this to check out here. So even though we didn't talk about it a whole lot, not real hard to show that one, and for future years, probably should have that example in there.